In 1912, a German meteorologist named Alfred Wegener placed two fossil impressions side by side, one lifted from Brazilian sandstone, the other chipped from a cliff face in West Africa, and noticed the leaves matched. The fern was called Glossop teres. It had been dead for roughly 250 million years, yet its imprint pressed into rock on opposite sides of the Atlantic still aligned as precisely as torn paper held back together. Pangea had no formal name yet. But the silence between those two stones was already asking something. What else might once have been whole before the ground beneath it chose to drift apart? Tonight we sit with a quieter version of that question. What if Pangea once held a civilization we will never find, not a buried city waiting for the right excavation, not a golden age concealed by conspiracy or catastrophe, something less solid than that, a way of living, moving and remembering, shared across land that had not yet learned how to divide itself, that left behind almost nothing permanent because it never needed permanence. This is not a claim, it is an exploration, and we will move through it gently, following three kinds of traces: the ones written in stone, the ones carried in story, and the ones that exist only as absence gaps in the record, and where something may have stood but left no footprint heavy enough to survive. Before we go further, it helps to understand what Pangea actually was, not as a dramatic image from a textbook diagram, but as a condition, a phase of Earth's deep life that lasted far longer than anything human. From roughly 335 million years ago to about 175 million years ago, nearly all of Earth's land existed as a single connected mass. One surface. One continuous rim meeting one global ocean called Panthalassa. For 160 million years the ground did not separate. It simply stayed. That duration matters. Human civilization, everything from the earliest known agriculture to this sentence, fits inside roughly 12,000 years. Pangea endured for more than 13,000 times that span. The patience of it is almost impossible to hold in mind. And yet here is where honesty must sit beside imagination. Modern humans appeared only about 300,000 years ago, more than 170 million years after Pangea broke apart. No anatomically modern person ever walked that supercontinent. Dinosaurs did, early reptiles did. Forests of ferns and conifers grew and fell across its interior for epochs, but humans as we know ourselves arrived long after the land had already cast into the shapes we recognize on maps today. So why ask the question at all? Because Pangea did not vanish all at once. Its remnants, Gondwana in the south, Laurasia in the north, lingered for tens of millions of years afterward. Land bridges persisted far longer still. During ice ages as recently as 20,000 years ago, sea levels dropped by as much as 120 meters, exposing corridors between land masses that are now deep ocean floor. The world early humans actually inherited was not the neatly fragmented globe we see on modern maps. It was something in between, more connected than today, less unified than Pangea, but still shaped by the memory of older arrangements. Coastlines that now face each other across thousands of kilometers of open water once stood close enough to walk between. And this is where the question shifts from geology into something more uncertain and more interesting. The earliest known complex civilizations, Mesopotamia, the Indus Valley, ancient Egypt, early China, appear in the archaeological record already remarkably sophisticated. They possess agriculture, architecture, astronomy, social hierarchy. They do not emerge from nothing, of course. Decades of careful research have traced developmental stages leading to each, but those stages themselves often seem to begin mid-sentence, as though a longer conversation preceded them, one that was spoken rather than written, carried rather than carved, practiced across landscapes that no longer exist in their former shape. What if that longer conversation happened across a world still echoing Pangea's connectivity? Not on the supercontinent itself, the timeline forbids that clearly, but on land still remembering what it meant to be joined, where knowledge travelled in footsteps rather than ships, and culture spread along gradients of terrain and climate rather than leaping across voids of open sea. This is the territory we enter tonight. Not to prove that such a civilization existed. Proof may be permanently beyond reach, and that honesty is part of what makes the question worth asking rather than answering. We enter it to explore what such a world might have felt like. How movement across unbroken ground could shape the way people think, cooperate, remember, and pass knowledge forward. How geography itself participates quietly in what becomes possible and what becomes invisible to the future. Along the way, we will consider the interior of a supercontinent where summer heat could bake exposed stone and winter cold could crack it wide open. We will sit with the idea that nomadic cultures by their very nature leave behind almost nothing for archaeologists to recover, not because those cultures lacked complexity, but because their complexity lived in memory, in oral tradition, in seasonal roots refined across centuries and carried in voices rather than monuments. We will notice how flood myths surface across civilizations now separated by entire oceans. How linguistic families spread in patterns that suggest slow, patient diffusion over connected ground rather than sudden independent invention. How the same constellations may have inspired parallel stories on opposite sides of the world. None of these traces taken alone prove a single shared origin. But laid together, they outline a shape faint, partial, possibly imagined where something coherent might once have been. There is no verdict waiting at the end of this, only a landscape of questions offered, quietly the way the Earth itself reveals its layers one stratum at a time without rushing, without insisting on being understood all at once. We begin where the land begins, with what Pangea looked like beneath skies no human eye ever saw, and what it might have demanded of any creature patient enough to learn its surface by foot. The shape of a world without edges, 300 million years ago, give or take a margin wide enough to swallow entire evolutionary epochs, the coastline of what would one day become West Africa, pressed flush against the eastern seaboard of a future South America. No water ran between them, no Atlantic existed even as a concept. The rock was continuous, the same red sandstone, the same bedding plains, the same fossilized river channels flowing across what is now open ocean. If you could stand at that junction, the warmth underfoot would come not from sunlight alone, but from the sheer mass of accumulated continental crust insulating the mantle heat below. Pangea did not merely sit on the Earth's surface. It trapped warmth beneath itself like a stone lid left too long over a slow fire. That thermal detail matters more than it might seem at first. Because the shape of Pangea was not simply a map outline, it was a climate engine, and the climate it produced across its interior was unlike anything modern humans have ever experienced on any continent we know. The interior stretched for thousands of kilometers in every direction away from the nearest coastline. Ocean moisture, which today softens the seasons across most inhabited land, could not reach those central regions. What climate scientists now call the Pangean megamonsoon dominated weather patterns, a seasonal system so vast that its wet phase drenched certain coastal margins while leaving the deep interior parched for months or years at a time. Rainfall in those inner zones was not merely low, it was episodic. It arrived in violent pulses, carved flash channels into hardened ground, fed temporary lakes that bloomed with microbial life for weeks, then evaporated under skies that offered no shade and no mercy. The dry intervals between could stretch long enough to crack stone. Temperature swings compounded the harshness. Without the thermal buffering of nearby oceans, daytime heat in the interior could climb to extremes that would challenge even modern desert adapted species. Nights, by contrast, drop sharply. The diurnal range, the gap between the hottest and coldest hours of a single day, may have exceeded 40 degrees Celsius in some inland basins. That is not a comfortable place. It is a place that filters. Anything living there had to tolerate not just heat or cold, but the constant oscillation between both day after day, season after season for geological spans of time. Yet life persisted. It persisted because harshness, when it is predictable, becomes learnable. Extremes that repeat in recognizable cycles are not the same as extremes that arrive without warning. The interior of Pangea was brutal, but it was not random. Its rhythms could be read by hydro roots that grew deep enough to find water tables, by reptiles that burrowed during the worst hours, by early synapsids, whose metabolic flexibility allowed them to function across wider thermal bands than their competitors. The land selected for patience, for efficiency, for the ability to wait. Closer to the coast, the world softened. Moisture arrived more reliably. Forests thickened in belts that followed rainfall gradients, shifting latitude with the slow wobble of Earth's axial tilt over millennia. River systems carried sediment from the interior highlands to broad flat deltas, where life concentrated in density and variety. These margins were not paradise storms with frequent erosion relentless and competition for fertile ground, as old as life itself, but they were dependable. And dependability in deep time is the closest thing to invitation. Between the punishing interior and the gentler coasts lay a transitional zone. Semi-arid scrubland seasonal grasslands, scattered woodlands fed by underground aquifers. This middle band is often overlooked in popular descriptions of Pangea, which tend to favour the dramatic extremes. But it may be the most important region of all, because it is precisely in these transitional environments, neither too harsh nor too easy, that adaptive pressure produces the most versatile organisms. Not the most specialised, not the most dominant, the most flexible. Consider for a moment what flexibility means across deep time. A species locked into a narrow ecological niche thrives when conditions hold but collapses when they shift. A species capable of exploiting a range of food sources, tolerating a range of temperatures and adjusting its behaviour to a range of seasonal patterns survives the shifts. It does not merely endure, it learns in the evolutionary sense that change is normal and that rigidity is a form of fragility. Pangea's transitional zones were nurseries for exactly this kind of adaptability. They rewarded not strength but responsiveness. None of this, of course, involved humans. The creatures navigating those transitional bands were reptiles, early mammal-like synapsids, insects, amphibians clinging to riverine corridors. Homo sapiens would not appear for another 270 million years after Pangea began to form. The timeline is not ambiguous. It is enormous. And yet the land itself was already practicing something that looks from a great distance like a rehearsal, establishing the environmental logic that would later shape how intelligence, cooperation and memory might develop in any species flexible enough to inherit it. The mountains that rose where tectonic plates collided during Pangea's assembly, the central Pangean mountains, remnants of which survive today as the worn-down Appalachians in North America and the Scottish Highlands in Europe. These ranges divided weather systems, channeled winds and created rain shadows that defined which side of a ridge received moisture and which did not. A single mountain range could mean the difference between forest and desert within a few hundred kilometers. Movement across such a landscape required not just endurance but knowledge. Knowledge of where water collected, where shade persisted, where food could be found after the rains. That kind of knowledge, once it exists in a species capable of transmitting, it does not stay in one place. It moves, it follows the creatures who carry it. And on a supercontinent where land connects rather than divides, it has nowhere it cannot eventually reach. Whether anything resembling organizers' knowledge ever travelled those routes during Pangea's own lifetime remains beyond our ability to answer. But the routes themselves, carved by rivers, shaped by climate, filtered by geology, those we can still trace. They are written in the rock that remembers being one continuous surface, even now, hundreds of millions of years after the first cracks began to whisper that the ground was planning to move on. What remained after the ground decided to leave. A single rift does not announce itself the way we imagine catastrophe should. It does not split the earth in a dramatic flourish visible from horizon to horizon. It begins as a thinning, a slow, almost imperceptible stretch in the crust where mantle heat has been building for millions of years beneath the insulating weight of a supercontinent. The first sign at the surface might be nothing more than a shallow depression, a place where water collects slightly longer than it used to, where the soil feels different underfoot without anyone being able to say precisely why. Pangea did not shatter. It softened along seams that had been warming, silence for epochs, and then with geological patience that makes even evolution look hurried, it began to pull itself into pieces that would one day carry names like Africa, South America, India, and Antarctica. The process took tens of millions of years. That phrase is easy to write and almost impossible to feel. 10 million years is long enough for entire species to appear, diversify, and vanish without leaving a single fossil. It is long enough for mountain ranges to rise and erode back to rolling hills. And during all of that immeasurable time, the land was not yet fully separated. Gondwana, the southern mass that included future Africa, South America, Antarctica, Australia, and India, persisted as a coherent block long after the northern portion of Eurasia had begun its own slow fragmentation. For a span far exceeding the entire history of a complex human society, the southern continents remained connected, or very nearly so, their coastlines close enough that shallow seas between them came and went with the rhythm of glacial cycles. What we call the separation was for most of its duration something closer to hesitation. This matters because the world that early humans eventually inherited was not the neatly divided globe displayed on classroom walls. When Homo sapiens first appeared in Africa roughly 300,000 years ago, the continents had been drifting for over 100 million years, yet the arrangement was still markedly different from today. The Mediterranean was a contested seaway that had at least once dried almost entirely into a vast salt basin. The Red Sea was narrower. Southeast Asia extended further south into a landmass now called Sundaland, connecting present-day Borneo, Java and Sumatra to the mainland through lowland forests and river plains. Australia and New Guinea formed a single continent, Sahul separated from Sundaland by water gaps narrow enough that early humans crossed them, though exactly how remains one of the oldest unanswered questions in archaeology. And then there was Beringia. During glacial periods when enormous volumes of ocean water locked into continental ice sheets, global sea levels dropped by as much as 120 meters. That drop exposed a land bridge between Siberia and Alaska that was not a narrow isthmus, but an entire subcontinent over 1,000 kilometers wide at its greatest extent, covered in steppe grassland, grazed by mammoths and bison, and traversable on foot by anyone willing to endure the cold. Beringia existed intermittently for hundreds of thousands of years. It vanished most recently only about 11,000 years ago, swallowed by rising seas, as the last ice age released its grip. 11,000 years is not a deep time. It is shallow enough to touch. Some oral traditions among indigenous peoples of the Pacific Northwest describe landscapes and events that archaeologists have tentatively linked to conditions predating the final submersion of that land bridge. Memory, it seems, can sometimes outlast geography, though proving such connections remains extraordinarily difficult and appropriately contested. The point is not that these land bridges were Pangea. They were not. The supercontinent had been gone for over 150 million years before any human ancestor took a single step. But they were Pangea's echoes, residual consequences of a planet whose continental arrangements still carried the momentum of an earlier unity. Coastlines that faced each other across manageable distances did so because they had once been pressed together. Shallow seas that periodically drained into walkable corridors existed because the ocean basins between young continents had not yet widened to their modern dimensions. The world of early humanity was shaped quietly and structurally by the memory of a configuration no human ever witnessed. This is where a peculiar tension enters the story. Archaeology tells us that modern humans spread from Africa across every inhabited continent with remarkable speed in evolutionary terms almost instantaneously. Within perhaps 60,000 years of leaving Africa, human populations had reached Australia, crossed into Europe and Central Asia, eventually entered the Americas and settled Pacific islands that required open ocean voyaging across hundreds of kilometers of empty water. That expansion was not random. It followed corridors, coastal routes, river valleys, steppe highways, and crucially land bridges that existed only because sea levels cooperated during glacial periods. Remove those bridges, raise the seas to their current levels, and the expansion stalls. The routes close. The story changes. Some researchers have pointed out that the speed and breadth of this expansion implies a familiarity with movement itself, not just the physical capacity to walk long distances, which human physiology clearly supports, but a cultural orientation toward mobility, a comfort with leaving known ground, a social structure flexible enough to absorb new environments without collapsing. These are not traits that appear overnight. They suggest deep practice habits refined across far more generations than the expansion itself required. The question that lingers softly and without insistence is where that practice accumulated. In a fragmented world of isolated pockets, or in something wider, a landscape still connected enough to reward movement as a default strategy rather than a desperate gamble. The geological record cannot answer that question directly. It can only confirm that the world early humans moved through was more connected than the one we see on maps today, and that those connections were not accidental but structural consequences of a planet still slowly completing a separation that began when Pangea's interior grew too warm to hold itself together. The land bridges are gone now. Beringia sleeps beneath the Bering Strait. Sunderland lies under the South China Sea. The corridors that once invited footsteps flooded silent and largely invisible, but the paths they enabled left marks in the distribution of human genetic lineages, in the spread of tool traditions, in the persistent similarities between cultures that, by all rights of modern geography, should have nothing in common. Those marks are faint. They do not shout, but they remain patient as the stone that still remembers which continent once pressed against which, even after 100 million years of learning how to be apart. The civilizations that carried everything and left nothing behind. 12,000 years, that is roughly how far back the archaeological record offers anything resembling a continuous narrative of human social organization. Before that threshold, the evidence thins dramatically, not to nothing but to fragments, stone tools scattered across the ancient lake beds, ochre pigments smeared on cave walls as shells pierced for stringing, found hundreds of kilometers from the nearest coast, charcoal layers, suggesting controlled fire, in contexts that imply intention rather than accident. These fragments are real, they are meaningful, but they are also, by their nature, the remnants of activities that happen to involve durable materials. They capture what was made of stone, bone and mineral. They are nearly silent about everything else, about what was spoken, sung, demonstrated, carried in a memory, or practiced using wood, fibre, skin and sound, all of which dissolve back into the earth within decades or centuries, leaving behind no trace that even the most careful excavation could recover. This is not a failure of archaeology. It is a condition of the material world. Organic matter decays. Spoken language leaves no residue. A migration route memorized across generations and transmitted through story produces no artifact unless someone carves it into rock, and even then the carving preserves the symbol, not the knowledge system that gave it meaning. The overwhelming majority of what early humans knew, believed, practiced and transmitted to their children is permanently invisible to us, not because it was simple or unimportant, but because it was encoded in media that the earth reclaims. The question that follows from this is uncomfortable in its simplicity. How much of what we call the beginning of civilization is actually the beginning, and how much is merely the point at which civilization began leaving behind material sturdy enough for us to find and to consider what a nomadic culture requires in order to function across deep time? It requires knowledge of landscape, not abstract cartographic knowledge, but embodied seasonal and relational understanding of where water appears, and when which plants fruit, in which months, where animals concentrate during dry periods, which mountain passes remain open through winter, and which routes become impassable after heavy rains. This is not trivial information. It is an operating system for survival, and it must be transmitted accurately across generations without the aid of any external storage medium. No written text, no permanent archive. Only human memory structured by the narrative, reinforced by repetition, and anchored to environmental cues that the learner can observe directly. The sophistication required to maintain such a system over centuries, let alone millennia, is routinely underestimated precisely because it leaves nothing behind that we can hold in our hands. Aboriginal Australians offer what may be the most striking example available to modern scholarship. Research published in the last 2 decades has documented oral traditions among Indigenous Australian communities that appear to preserve accurate descriptions of coastal geography as it existed 7,000 years ago, and possibly longer descriptions of bays that are now submerged of land that extended kilometres beyond present shorelines of places where people once walked, that are now deep underwater. These are not vague mythological gestures toward a watery past. They contain specific spatial relationships, specific landmarks, specific sequences of landscape change that correlate with independently established geological and sea level data. 7,000 years of oral transmission maintained without writing, without institutional support in the modern sense, and without any of the archival infrastructure that literate civilizations consider essential for preserving knowledge across even a few centuries. The detail is small in the context of deep time, but it refuses to go away because it suggests that human memory, when structured by culture and environment, is capable of far more than we typically credit. If such accuracy can be sustained for 7 millennia within a single cultural tradition on a single continent, the natural question is, what might have been sustained across longer periods in a more connected world? This is not a question that demands an answer. It is a question that reframes how we interpret absence. When archaeologists find no evidence of complex social organization before a certain date, the default interpretation is that such organization did not yet exist. But that interpretation rests on an assumption that complexity necessarily produces durable physical evidence. Nomadic complexity, by contrast, produces knowledge, coordination, and social structures that are extraordinary in their sophistication and nearly invisible in their material footprint. A group that can coordinate seasonal movement across hundreds of kilometers, manage resource, access among neighboring bands without centralized authority, and maintain accurate environmental knowledge across dozens of generations is not simple. It is complex in a direction that archaeology struggles to detect. On a connected landmass, whether Pangea itself or any of its long-lived successor configurations, such complexity could operate at scales that a fragmented world does not easily permit. When land is continuous, movement is not interrupted by the categorical barrier of open ocean. Groups can shift gradually across climate zones, following resources, avoiding scarcity, encountering other groups, exchanging knowledge and adjusting practices through contact rather than isolation. None of this requires cities. None of it requires writing. None of it requires any of the material markers that we conventionally associate with the word civilization. It requires only what humans are already exceptionally good at: walking, remembering, talking, and teaching. The absence of physical evidence then does not necessarily indicate the absence of organized life. It may indicate the presence of a kind of organized life that we have not yet learned how to see, or that by its very nature cannot be seen through the methods we currently possess. Some researchers frame this more cautiously, noting that absence of evidence is not evidence of absence, but also not evidence of presence, and that the gap between possibility and demonstration remains wide. That caution is appropriate. It is also in a sense the entire point. We are not attempting to prove that a civilization existed on Pangea or on any of its remnants. We are attempting to notice that our tools for detecting the past have a bias toward permanence, towards stone, towards settled life, and that this bias shapes what we are capable of concluding. Everything that was carried rather than built, spoken rather than inscribed, practiced rather than constructed, falls outside the reach of that bias. It is not gone because it was unimportant. It is gone because it was made of the wrong material for survival across geological time. What remains then is pattern, not proof but recurrence, not a single artifact that settles the question, but a series of quiet correspondences in myth, in tool-making tradition, in linguistic structure and the distribution of cultural practices across regions that seem too distant for coincidence, but too similar for complete independence. Whether those patterns reflect a deep shared heritage carried across connected ground, or whether they reflect the universal tendencies of a single species solving similar problems under similar pressures, is a question that may never be fully resolved. But the patterns themselves are real. They exist in the record patient and uninsistent waiting, not to be believed but simply to be noticed, the way a path through tall grass is visible only from the right angle, and only if you are willing to look long enough for the faint line where the stems bend slightly differently from the rest. Fire that travelled without being carried. A piece of flint found in a South African cave called Wonderwork shows microscopic traces of controlled burning dating to roughly 1 million years ago. Ash layers too thin and too localized to be wildfire, too consistently associated with tool fragments and animal bone to be accidental. It is not the oldest evidence of fire use, but it is among the most quietly persuasive because the cave itself sits deep enough that lightning could not have reached the burn site, and the ash composition suggests sustained low-temperature combustion of grasses and small branches, rather than the flash heat of a natural blaze sweeping through. Someone or something with intention resembling someone brought fire into that cave and kept it alive long enough to leave a signature in the sediment. That signature has survived for 1 million years. The hands that fed the flame have not, and yet the knowledge those hands carried, the understanding that fire could be maintained, directed and used, did not stay in one cave or one valley. It moved, slowly, unevenly across the distances that accumulate into something extraordinary when measured, not in single lifetimes, but in the deep time that a connected landmass affords. Fire is often described as the technology, and it is, but that framing misses something essential about what fire meant before it was reliably ignitable. For most of the period during which early hominins interacted with fire, they could not create it on demand. Lightning strikes ignited grasslands. Volcanic activity set forests smouldering. Dry seasons turned deadfall into tinder that a single spark could activate. What early humans learned first was not how to start fire, but how to recognize it, approach it, preserve it, and carry it forward, sometimes literally, as a mouldering ember wrapped in green leaves or damp moss, guarded against wind and rain with the kind of sustained attention that implies fire was understood, not as a tool to be picked up and put down, but as a relationship that required ongoing care. A group that lost its fire might wait generations before encountering it again, unless another group nearby still maintained theirs. In a fragmented world of isolated populations separated by water, that loss could be permanent. In a connected world where groups encountered one another through overlapping migration routes, the loss was recoverable. Fire could be reobtained through contact. Knowledge of its maintenance could be observed, imitated, and absorbed without formal instruction. This distinction between permanent loss and recoverable loss is one of the quietest advantages that connected land offers to any species capable of social learning. The implications extend well beyond fire itself. Every form of early technology follows a similar logic. A sharper stone edge, a more effective hafting technique, a method of processing plant fibers into cordage. Each of these innovations requires time and repetition to develop, but once developed, it can spread through observation far more efficiently than it can be independently reinvented. The critical variable is contact. Innovation in isolation must be rediscovered every time it is lost. Innovation within a network of intermittent contact accumulates, because even if one group loses a technique, another group somewhere along the chain of connection still practices it and the knowledge can flow back. On a supercontinent or on any sufficiently connected landmass, this network effect operates at continental scale. A technique refined along one river system can over centuries of gradual movement and encounter reach populations thousands of kilometers away. Not through trade in the modern sense, not through deliberate transmission, simply through the ordinary process of people meeting other people, noticing what they do differently and remembering what works. Archaeology offers tantalizing glimpses of this process, even in the fragmented world we know. Obsidian volcanic glass, prized for its ability to fracture into edges sharper than surgical steel, has been found at archaeological sites located 200, 300, sometimes over 400 kilometers from its nearest geological source. Each piece of obsidian carries a chemical fingerprint that can be matched to a specific volcanic origin, allowing researchers to trace its movement across landscapes with surprising precision. These are not trade routes in the institutional sense. They are diffusion paths, evidence that materials, and presumably the knowledge of how to work them, passed from hand to hand across distances that no single individual needed to traverse entirely. The obsidian moved farther than any one person carried, by a chain of exchanges so informal that no participant may have understood the full extent of the network they belonged to. Some researchers argue these patterns mean nothing more than opportunistic exchange among neighbouring bands, each passing a useful stone a short distance before it was passed again. And yet the distances involved and the consistency of the directional flow suggest something more structured than pure accident, a quiet current of material and knowledge, moving along paths that geography and habit made reliable. Now extend that logic backward into a world where the paths were longer and the barriers fewer. On Pangea's transitional zones, the semi-arid bands between the brutal interior and the milder coasts movement was not only possible but likely necessary for survival. Seasonal shifts in water and food availability would have pushed populations along predictable corridors, creating exactly the kind of repeated overlapping contact that allows knowledge to diffuse without anyone planning its transmission. Fire, maintenance techniques, tool-making methods, knowledge of edible plants, strategies for avoiding predators, all of these could travel the same corridors, embedded in the daily practices of groups that encountered one another, not as strangers but as familiar variations on a shared way of living. The result over deep time would not be a single uniform culture. It would be something more like a gradient, practices shifting gradually across distance, recognizable in their logic, even when different in their specifics, the way a dialect remains intelligible long after the accent has changed beyond easy recognition. This gradient model of cultural diffusion challenges the assumption that early human life was defined primarily by isolation. Isolation certainly existed, especially in harsh interior zones where populations were small and widely spaced. But isolation on a connected landmass is different in character from isolation on an island or a peninsula, cut off by rising seas. It is temporary rather than structural. It can be broken by a wet season that opens a previously dry corridor, by a shift in animal migration that draws two groups into proximity, by the simple arithmetic of population growth pushing bands into contact with neighbours they had not encountered for generations. Every such contact is an opportunity for knowledge to move. And knowledge, unlike stone or bone, leaves no trace of its passage, only its effects visible in the sudden appearance of a new technique, or the quiet refinement of an old one across a region too wide for any single group to have traversed alone. What fire teaches more than anything is that survival in deep time is not a solitary achievement. It is a network property. The groups that endured were not necessarily the strongest or the most inventive. They were the most connected, the ones embedded in webs of contact dense enough that a lost technique could be recovered, a failed strategy could be corrected by observation, and a useful innovation could spread before the generation that discovered it disappeared. Fire did not travel because someone decided to carry it across a continent. It travelled because the continent allowed people to keep meeting each other, and every meeting was a chance for something useful to pass from one set of hands to another, quiet as an ember, wrapped in leaves glowing just enough to survive the journey. Stories that arrived before the storytellers. How does a myth cross an ocean if the people who carry it never learn to sail? The question sounds like it should have an obvious answer. It doesn't, it can't. The similarities are coincidence. And in many cases that answer is probably correct. Human minds facing similar problems under similar pressures will often produce similar solutions, including similar stories. A species that depends on fresh water and lives along rivers will likely develop narratives about floods. A species that navigates by stars will likely attach meaning to constellations. A species that fears predators will likely populate its mythology with powerful, dangerous animals. These convergences require no ancient contact, no shared ancestry, no lost motherland. They require only the universal architecture of a human brain responding to the universal conditions of a human life. That explanation is clean, efficient, and in many instances almost certainly sufficient. And yet it does not account for everything. There are patterns in the global distribution of myth that fit poorly into the framework of independent invention, not because they are too similar, but because they are similar in ways that seem structurally unnecessary. Flood myths, for instance, appear across cultures on every inhabited continent. Mesopotamia, South Asia, indigenous Australian traditions, Pacific Island oral histories, multiple distinct traditions across the Americas. The prevalence alone is not surprising given that most early human populations lived near water and experienced flooding as a regular environmental reality. What is harder to explain through independent invention alone is the narrative architecture that many of these myths share: a warning, ignored or unheard, a period of inundation that transforms the known world, a small group of survivors who carry forward the memory of what was lost, and a slow rebuilding in a landscape that is no longer the same. These structural parallels go beyond the mere fact of flooding. They encode a specific emotional and temporal sequence, lost survival transformation that repeats with a consistency some researchers find difficult to attribute entirely to coincidence. The same quiet pattern appears in other mythological domains. Serpent or dragon figures recur across cultures separated by thousands of kilometers of open ocean. Not merely as dangerous animals which would be expected wherever snakes exist, but as cosmic agents associated with water, creation, destruction, or the boundary between the living world and whatever lies beneath it. World trees, vertical structures connecting an upper realm, a middle realm, and a lower realm, appear in Norse, Mesoamerican, Siberian, and South Asian traditions, with structural similarities that exceed what a shared fear of heights or a shared admiration for large trees might reasonably produce. Sacred mountains serve as axis points in cosmologies from Greece to Japan to the Andes, functioning not just as impressive geological features but as narrative anchors for the relationship between Earth and sky. None of these parallels taken individually constitute evidence of contact or shared origin. Each can be explained with varying degrees of persuasiveness as the independent product of universal human cognition operating on universal environmental inputs. But when they're considered together not as a proof but as a pattern, something shifts. The weight of recurrence begins to feel less like coincidence and more like inheritance, though from what source and through what mechanism remains genuinely unclear. Linguistics adds another layer to this uncertainty. The historical study of language families reveals patterns of divergence that can sometimes be traced backward toward common ancestors: Proto-Indo-European Proto, Afro-Asiatic Proto, Austronesian, each representing a point in time when a single linguistic community began to fragment into daughter languages that would eventually become mutually unintelligible. These reconstructions rarely reach beyond 6,000 or 7,000 years, with any confidence and attempts to push further into deep time so-called macro-family hypotheses linking Indo-European to other major families remain controversial and largely unaccepted by mainstream linguistics. The data simply becomes too degraded. Sound shifts accumulate. Borrowings contaminate the signal. The further back you look, the harder it becomes to distinguish genuine inheritance from structural accident. But the pattern of divergence itself is telling. Languages do not branch randomly. They branch along geographic lines, following the movement of populations across land, splitting more sharply where barriers intervene, mountains, deserts, and above all water. On a connected landmass, linguistic divergence would proceed more slowly, producing broad dialect continua rather than sharp family boundaries. The fragments we can reconstruct may represent only the most recent layer of a much older process of linguistic diffusion that operated under geographic conditions very different from those that exist today. What would such a process look like if we could somehow observe it? Not a single language spoken from coast to coast that has never been plausible for any landmass of significant size. Rather, a continuous field of mutual intelligibility shifting gradually over distance, the way temperature shifts with latitude. A traveller moving slowly across connected ground might notice speech changing around them, new words appearing, old ones dropping away, pronunciation drifting, but at no point would they encounter a hard boundary where understanding simply stops. Communication would degrade gracefully rather than failing categorically. This is exactly what linguists observe in regions where language contact is sustained and geographic barriers are minimal. It's exactly what they do not observe where oceans, mountain ranges, or deserts create sharp divisions. The implication is not that Pangea produced a universal language. The implication is that connected land produces connected speech, and that the sharp linguistic boundaries we observe today may be relatively recent consequences of geographic fragmentation rather than ancient features of human communication. These threads, mythological, linguistic, structural, do not weave together into a conclusion. They weave together into a question, and the question is whether the patterns we observe across separated cultures are best explained as independent responses to universal conditions or as the residue of a longer period of contact that geography eventually interrupted. The honest answer is that we do not know. Both explanations have merit, both have limits, and the space between them, that uncertain, uncomfortable middle ground, where evidence suggests but does not confirm, is precisely where the most interesting questions tend to live patient as sediment, waiting not for resolution, but for the willingness to sit with ambiguity long enough to notice what it contains. The weight of what we cannot show, every compelling pattern deserves an honest reckoning with the possibility that it is not what it appears to be. The human mind is among its many remarkable qualities an extraordinarily aggressive pattern detection machine, so aggressive in fact that it routinely finds structure in randomness, narrative in noise and connection, where none exists. This is not a flaw. It is one of the cognitive traits that made survival possible in unpredictable environments, because the cost of seeing a pattern that isn't there is almost always lower than the cost of missing one that is. A rustle in the grass that turns out to be wind is a minor embarrassment. A rustler in the grass that turns out to be a predator, ignored because the listener dismissed the pattern, is fatal. Evolution selects for oversensitivity. We are the descendants of the ones who flinched, and that inheritance means that when we look at the distribution of myths, the spread of tool traditions, or the structural similarities between cultures separated by oceans, we must ask ourselves seriously whether we are detecting a real signal or responding to a cognitive reflex that has been rewarding false positives for 300,000 years. The first and most substantial counterargument to any hypothesis of deep shared cultural origin is the timeline itself, and it cannot be softened or worked around. Pangea existed as a unified supercontinent between roughly 335 and 175 million years ago. Homo sapiens appeared approximately 300,000 years ago. The gap between the two is not a matter of missing evidence or imprecise dating. It is a chasm of over 170 million years a span, during which entire classes of animal life appeared. Diversified, dominated the planet and went extinct. Dinosaurs rose and fell within that gap. Flowering plants evolved. The Atlantic Ocean opened from a narrow rift into a body of water thousands of kilometers wide. No mechanism known to science permits cultural transmission across such a divide. There is no bridge of oral tradition, no chain of memory, no conceivable continuity of practice that could survive 170 million years of biological turnover. Whatever patterns we observe in human cultures today cannot be attributed to life on Pangea itself. The supercontinent is a useful frame for thinking about connectivity, but it is not and cannot be a direct explanation for anything humans have done, thought, or remembered. The second counterargument addresses the mythological parallels more directly. Flood stories, serpent figures, world trees, sacred mountains. These recur across cultures, and their recurrence is genuinely striking. But striking is not the same as inexplicable. Cognitive scientists and anthropologists have spent decades developing frameworks that account for these parallels without invoking shared ancestry or ancient contact. The concept of universal human cognition, sometimes called psychic unity, proposes that brains built to the same biological specifications facing environments governed by the same physical laws will independently generate similar symbolic structures. Water is dangerous and life-giving everywhere. Snakes are among the most widespread predators that humans encounter across diverse ecosystems. Tall vertical structures, trees, mountains, columns of smoke naturally invite vertical cosmologies because human spatial cognition is organized around the axis of gravity. These are not cultural inheritances, they are cognitive inevitabilities, products of a brain that categorizes, narrates and symbolizes in predictable ways regardless of geographic context. The argument is powerful because it requires no extraordinary mechanism. It asks only that we take seriously the idea that similar minds produce similar myths, which is on its face entirely reasonable. A third line of skepticism concerns the archaeological absence itself and how it is interpreted. The observation that nomadic cultures leave minimal material traces is accurate. The conclusion sometimes drawn from that observation that sophisticated cultures may have existed and simply left nothing behind is far more problematic. Absence of evidence is not evidence of absence, as the saying goes, but neither is it evidence of presence. The fact that we cannot disprove the existence of a complex pre-agricultural civilization does not lend that civilization any positive support. It simply places the hypothesis beyond the reach of falsification, which in scientific terms is not a strength but a weakness. A claim that cannot in principle be tested against evidence is not a bold idea waiting for confirmation. It is an idea that has exempted itself from the process by which knowledge is built. Some researchers are blunt about this. The romantic appeal of lost civilizations, they argue, often correlates inversely with the rigor of the evidence offered in their favor, and the gap is typically filled not by data but by suggestion atmosphere and the seductive comfort of mystery. These objections deserve their full weight. They are not dismissals offered by people who lack imagination. They are guardrails maintained by disciplines that have learned through long and sometimes painful experience that the human desire to find meaningful patterns in the past is powerful enough to overwhelm the evidence if left unchecked. Archaeology, linguistics, and comparative mythology all carry scars from earlier eras when enthusiastic speculation outran the data, when diffusionist theories attributed every cultural similarity to a single origin point, when lost continents were proposed with more confidence than evidence, when the complexity of indigenous cultures was alternately denied or attributed to outside influence rather than recognised as the independent achievement it was, the caution of modern scholarship is not timidity, it is memory. And still, after all of that honest weight has been placed on the other side of the scale, the patterns do not entirely dissolve. The structural similarities in flood narratives across cultures that had no post-glacial contact remain difficult to fully explain through cognitive universalism alone, because the parallels are not merely thematic but sequential. They share narrative architecture, not just subject matter. The distribution of certain tool-making techniques across regions separated by water predates any known maritime technology capable of bridging the gap. The linguistic evidence, while too degraded for firm conclusions, consistently points toward deeper common roots than current models can comfortably accommodate. None of this constitutes proof. None of it overturns the legitimate objections, but it sits in the record with a quiet stubbornness that resists complete dismissal the way a faint mark on a cave wall resists being explained as natural erosion once you have noticed that it aligns with 3 other marks at regular intervals. It may be coincidence. It may be cognition doing what cognition does. It may be the residue of contact that here occurred not on Pangea itself. The timeline forbids that, but on later, still connected landscapes that Pangea's breakup had not yet finished dividing. The discomfort is that we cannot be certain which explanation is correct, and that certainty in this particular corner of human inquiry may not be available at any price. What remains is the willingness to hold the question open, not as belief, not as conclusion, but as attention directed toward patterns that have not yet been fully explained by any single framework and that continue to surface gently and persistently every time someone looks carefully enough at what separated cultures share beneath their differences. A body built for ground that does not end. The average human walking speed on flat terrain is roughly 5 km per hour. It is not an impressive number compared to almost any other large mammal. A horse at a comfortable trot covers that distance in less than half the time a wolf without effort, even a domestic dog on a casual outing. But speed is not what the human body was designed to optimize. What it was designed to optimize through millions of years of selection pressure in open landscapes is something far less dramatic and far more powerful: the ability to keep going. Not faster than other animals, but longer. Not with explosive force, but with a slow, patient thermoregulatory efficiency that allows a human being in reasonable condition to walk and walk and walk for distances that would exhaust or overheat nearly any quadruped on the planet. A horse can outrun a human over a short distance without question. Over 20 kilometers in midday heat, the outcome reverses. Over 40 is not even close. This is not a minor anatomical curiosity. It is a defining feature of the species, and it tells a story about the kind of world in which the human body was shaped. Upright posture exposes less surface area to direct sunlight than a horizontal body plan. The loss of most body hair, combined with an extraordinary density of sweat glands, roughly 2 to 4 million distributed across the skin, creates an evaporative cooling system unmatched by any other large terrestrial mammal. Long legs relative to body mass reduce the energetic cost of each stride. Achilles tendons store and release elastic energy with a mechanical efficiency that makes sustained walking remarkably cheap in caloric terms. Even the human foot, often dismissed as a compromised structure compared to the grasping feet of other primates, is in fact a highly specialized lever system optimized for repetitive ground contact over hard open terrain. Every major feature of human locomotion points in the same direction. This is a body built not for sprinting, not for climbing, not for swimming, but for covering ground, slowly, steadily across distances, measured not in minutes but in days. The persistence hunting hypothesis, supported by both physiological analysis and ethnographic observation of the groups like the San people of the Kalahari, proposes that early humans exploited exactly this advantage. Unable to outrun prey over short distances, they instead tracked animals across open landscapes during the hottest part of the day, maintaining a pace that prevented the quarry from resting long enough to cool down. Over hours, the animal's core temperature rose beyond tolerance. It collapsed. The human arrived walking barely winded by comparison, and completed the kill at close range with simple tools. This strategy requires no sophisticated weaponry. It requires endurance thermoregulation and, critically, the ability to track. Tracking is itself a cognitive skill of remarkable complexity, demanding the integration of visual pattern recognition, environmental knowledge, spatial memory, and predictive reasoning. A skilled tracker reads not just footprints, but bent grass, disturbed soil insect behavior, and the faintest traces of passage that most modern humans would never notice. It is in a real sense a form of applied science practiced without any of the formal apparatus we associate with that word. What matters here is the landscape such a strategy implies. Persistence hunting does not work in dense forest where sightlines are short and prey can disappear within seconds. It does not work well in highly fragmented terrain, broken by water barriers that interrupt the chase. It works best in open or semi-open environments, savannas, grasslands, transitional scrubland where visibility extends to the horizon and where movement is constrained by endurance rather than obstacles. These are precisely the environments that dominated Pangea's transitional zones and that continue to characterize large portions of Africa, Central Asia and other connected landmasses long after the supercontinent had fragmented. The human body, in other words, carries in its structure a memory of the kind of terrain it was shaped to move through terrain that rewards persistence over speed, continuity over interruption, and the patient accumulation of distance over time. That memory extends beyond hunting. Walking is not merely a survival strategy, it is for humans a mode of cognition. Research in environmental psychology has documented what many cultures have long understood intuitively, that sustained walking through varied terrain changes how the brain processes information. Attention broadens, pattern recognition sharpens. The rhythmic cadence of footfall appears to facilitate a particular quality of thought that is neither focused concentration nor idle distraction, but something in between, a state in which connections form more easily and memory consolidates more effectively. It is not coincidental that oral traditions in walking cultures tend to be organized spatially tied to landmarks, routes, and sequences of places encountered along a journey. The Aboriginal Australian songlines are the most extensively documented example, but analogous systems exist in traditions across the world. Knowledge is mapped onto landscape is traversed on foot, and the act of walking becomes simultaneously an act of remembering. On a connected landmass, this integration of movement and memory could extend across distances that modern geography does not permit. A route memorized and transmitted across generations could in principle span thousands of kilometers, not as a single journey, but as a linked sequence of segments, each maintained by the groups who lived along it, each connecting to the next through zones of overlapping familiarity. No single person would need to know the entire route. Each would know their portion and trust that others knew theirs. The system would be distributed, resilient, and capable of transmitting not just directional information, but ecological knowledge, seasonal timing, and social protocols for interacting with unfamiliar groups encountered along the way. It would look from the outside like nothing at all. No roads, no signposts, no infrastructure, visible to archaeological excavation. From the inside, it would function as a continental operating system maintained entirely in human memory and activated by the simple ancient physiologically optimized act of placing one foot in front of the other. When the land begins to fragment, when rising seas submerge coastal corridors, when rift valleys widen into straits, when familiar paths end abruptly. At water that was not there a generation ago, this system does not collapse all at once. It frays. Segments disconnect. Knowledge that once flowed along continuous routes pulls locally, maintained by the groups that still walk their portion, but no longer reinforced by contact with the groups who walked the next. Over time, the segments become traditions unto themselves, locally complete but globally orphaned. The continental operating system degrades into regional memory, each fragment preserving its portion of a larger whole that no single group can any longer perceive. And the body still built for open ground, still optimized for distances that no longer exist in unbroken form, carries forward a capacity that its environment no longer fully uses, like a key shaped for a lock that the ocean has quietly removed from the door, the same stars seen from different ground. On a clear night in the southern Kalahari, far from any artificial light source, the Milky Way does not appear as a faint smudge across the sky. It appears to structure a thick, luminous arch so dense with individual stars that it casts a visible shadow on pale sand. The San people of that region have a name for it that translates roughly as the backbone of the night, and their traditions describe it not as a distant phenomenon, but as something intimate, a feature of the world as immediate as a riverbed, or a ridgeline carrying meaning that is practical before it is symbolic. The stars tell you when to hunt, they tell you when certain plants will fruit, they tell you when the rains are approaching and when they are withdrawing. They are not decorations, they are instruments, and the knowledge of how to read them is transmitted with the same seriousness as the knowledge of how to find water or avoid a predator. This relationship between sky and survival is not unique to the San. It appears with local variation in virtually every pre-industrial culture ever documented, from the Polynesian navigators who crossed thousands of kilometers of open Pacific, guided by star paths memorized across generations, to the agricultural societies of ancient Mesopotamia, whose planting calendars were synchronized to the heliacal rising of specific stars. The sky, it seems, is one of the few teachers that every human culture has agreed to attend. What makes this agreement remarkable is not that it exists. The sky is after all unavoidable, but that it produces such structurally similar systems of interpretation across cultures that had no apparent means of contact. Constellations are arbitrary groupings. There is no physical reason why a particular cluster of stars should be associated with a bear, a hunter, a scorpion, or a river. The stars in any constellation are typically located at vastly different distances from Earth and have no actual spatial relationship to one another. The patterns exist only in the eye of the observer, projected onto a two-dimensional surface that the brain constructs from a three-dimensional scatter of unrelated light sources. And yet certain groupings recur across traditions with a frequency that exceeds what random projection might predict. The belt of Orion, 3 stars in a nearly straight line, is recognized as a distinct unit in Greek, Egyptian, Chinese, Aboriginal, Australian, and multiple indigenous American traditions. The Pleiades, a tight cluster visible to the naked eye, as a small fuzzy patch, appears in the mythologies of cultures spanning every inhabited continent, often associated with similar themes. A group of siblings, a seasonal marker, a story of loss or pursuit. Some researchers attribute these convergences to the simple visual salience of the groupings themselves. The belt is straight and obvious. The Pleiades are compact and eye-catching, and that explanation carries considerable weight. Stars that are easy to notice will be noticed independently by any culture that looks upward. But visual salience alone does not fully account for the narrative structures attached to these groupings, which in several cases share not just the identification of the pattern, but the type of story told about it. The Pleiades offer a particularly stubborn example. In Greek mythology, they are 7 sisters pursued by a hunter. In several Aboriginal Australian traditions, they are a group of young women pursued or threatened by a male figure associated with Orion. In Kiowa tradition from the North American plains, they are 7 sisters who escape a pursuer by climbing into the sky. In Japanese tradition, they are a cluster called Subaru, associated with unity and gathering. The pursuit motif, young women fleeing a male figure, appears across traditions separated by the Pacific Ocean, the Indian Ocean, and tens of thousands of years of independent cultural development. It is possible that this is coincidence amplified by selective attention that researchers have unconsciously focused on traditions that match while ignoring those that do not. It is possible that the visual relationship between the Pleiades and the nearby constellation Orion, one compact and delicate the other, large and assertive, naturally invites a narrative of pursuit, regardless of cultural context. These explanations are reasonable and may be correct. But the specificity of the shared structure, not just stars in a story, but a group of women, a pursuing figure in an act of escape or transformation, sits in the comparative record with a weight that purely cognitive explanations have not yet fully lifted. On a connected landmass, such correspondences become easier to account for without requiring either miraculous coincidence or supernatural transmission. Stories attached to stars are among the most stable forms of oral tradition precisely because their referent returns every night. A myth anchored to a constellation is reinforced every time the constellation appears. It does not drift the way a story attached to a river might drift when the river changes course, or the way a story attached to an animal might drift when the species migrates out of a region. The stars are for all practical purposes within a human timescale permanent. A story told about the Pleiades 10,000 years ago can still be checked against the sky tonight. This stability makes stellar myths ideal vehicles for long-distance cultural transmission. A narrative that travels with a migrating group retains its accuracy because the sky confirms it at every campsite along the route. It does not require reinterpretation when the landscape changes. It does not lose its reference when a group moves from forest to grassland or from lowland to highland. The stars remain constant. The story remains anchored. This anchoring effect has a second subtler consequence. It synchronizes time across distance. When groups separated by hundreds or thousands of kilometers observe the same stars rising at the same seasons, their ceremonial calendars tend to align, even without direct coordination. Planting times, hunting seasons, gathering periods, and ritual observances keyed to stellar events will naturally cluster around the same points in the annual cycle. This produces a phenomenon that might be called passive synchronization, a coordination of behavior across space that requires no central authority, no communication network, and no shared political structure. It requires only a shared sky and a shared habit of paying attention to it. On a fragmented world divided by oceans, this synchronization still occurs, but is limited by the fact that different latitudes see different skies. A constellation prominent in the northern hemisphere may be invisible from the southern. Stellar calendars diverge as groups move to different parts of the globe. On a connected landmass, particularly one spanning a broad but continuous range of latitudes like Pangea, the shared sky extends further. More groups see more of the same stars. Synchronization persists over wider areas. The cultural consequences are difficult to quantify, but easy to imagine a world where seasonal rhythms resonate across enormous distances, where ceremonies echo one another without anyone planning. The echo where the sense of belonging to a larger pattern is reinforced every clear night by the simple act of looking upward. When continents separate and populations find themselves on opposite sides of widening oceans, this resonance does not vanish immediately. The stars are still there. The stories are still told. But the reinforcement of contact, the slow generational process by which neighbouring groups confirm and calibrate each other's traditions, weakens. Stories begin to drift. Calendars diverge. The same constellation acquires different names, different narratives, different ritual associations. The underlying structure persists longer than the surface details, which is why comparative mythology can still detect deep similarities beneath centuries of independent elaboration. But even the structure eventually fades without reinforcement the way a path through grassland remains visible for a season after the last foot crosses it, then gradually disappears beneath new growth until only someone who knew where to look could tell that anyone had ever walked there at all. When the path ended, Memorisham had to change shape. What happens to knowledge when the route it travels along ceases to exist? Not gradually, not through slow disuse, but structurally, the ground itself is sinking beneath water, the corridor that once connected two regions becoming a strait, then a sea, then an ocean too wide for any technology available at the time to cross. The knowledge does not vanish in the moment the path floods. It persists in the people who carry it intact and functional for as long as those people continue to practice and transmit it. But without reinforcement from the network that once sustained it, without the periodic contact with distant groups that confirmed, corrected, and enriched shared understanding, that knowledge begins to change. It does not decay uniformly. It localizes. The portions most relevant to immediate surroundings are maintained with precision. The portions that refer to distant places, distant practices, distant relationships lose their practical anchor and begin to drift toward abstraction, toward myth, toward the kind of poetic compression that preserves emotional truth while releasing factual specificity. A route once described in precise seasonal and geographic terms becomes a story about ancestors who walked a great distance. A technique once shared across a network becomes a local tradition, shui, whose origin is attributed to a founding figure rather than to a chain of anonymous exchange. Memory denied its medium of movement does not disappear. It crystallizes harder, more defined and more brittle than the fluid knowledge it replaced. This crystallization is not a metaphor. It has material consequences that appear in the archaeological record at precisely the moments when geographic fragmentation accelerates. The emergence of agriculture, which conventional narratives present as a revolutionary breakthrough driven by human ingenuity, can also be read as a response to constraint. When movement across large distances becomes difficult or impossible, when rising seas close land bridges, when expanding deserts cut migration corridors, when populations grow dense enough that relocation is no longer a viable solution to resource pressure, the strategy of moving to where food grows naturally gives way to the strategy of making food grow where you already are. Agriculture does not require more intelligence than nomadic foraging. In many respects, it requires less environmental knowledge, less spatial memory, less ecological sensitivity. What it requires is investment in place, and that investment becomes rational only when the alternative movement has been sufficiently degraded by geographic change. The earliest known sites of agricultural development cluster in regions where this logic applies clearly: the Fertile Crescent, where the post-glacial flooding of the Persian Gulf and the drying of surrounding landscapes compressed populations into a narrow band of viable territory; the Yangtze River Basin, where rising sea levels pushed coastal populations inland; the highlands of Mesoamerica, where volcanic terrain and seasonal water scarcity created pockets of habitable land, surrounded by zones too harsh for reliable foraging. In each case, the pattern suggests not a sudden leap of creativity, but a slow foreclosure of alternatives. People settled because the paths closed. They farmed because they could no longer walk to where food already existed. They built because they were staying. And once they were staying, a cascade of secondary developments followed with a logic that feels almost inevitable in retrospect. Storage becomes necessary when you cannot simply move to the next seasonal abundance. Surplus creates the possibility and the problem of unequal accumulation. Ownership emerges as a concept when land is improved through labour and cannot be easily replaced by walking to the next valley. Authority formalizes when disputes over fixed resources cannot be resolved by the simple expedient of one party leaving. Writing, when it finally appears roughly 5,000 years ago in Mesopotamia, does not emerge as a tool for recording poetry or philosophy. It emerges as a tool for recording transactions, quantities of grain, allocations of labour, debts owed and payments made. The earliest known writing system, proto-cuneiform, is an accounting technology. It externalizes memory, not because human memory has suddenly become inadequate, but because the kind of memory now required precise numerical tied to ownership and obligation is different from the kind that oral tradition excels at preserving. Oral memory is narrative, spatial, and associative. It remembers roots, relationships, and sequences of events. It is less suited to remembering that 14 units of barley were delivered to a specific storehouse on a specific date, and that 6 remain owed. Writing fills a gap that settlement creates, and settlement fills a gap that geographic fragmentation imposes. This sequence, fragmentation, settlement, surplus, hierarchy writing, is sometimes presented as the story of civilization's origin, as though civilization begins at the moment humans stop moving and start building. But that framing quietly erases everything that came before. It treats the long millennia of mobile, oral, and network-based human culture as a prelude, a waiting period before the real story starts. The alternative framing, which the evidence supports at least as well, is that settlement and writing are not the beginning of complexity, but a translation of it. The complexity already existed. It existed in the knowledge systems that organized movement across connected landscapes, in the social structures that coordinated resource access among mobile groups, in the oral traditions that preserved environmental information across centuries with remarkable accuracy. What changed was not the presence of complexity, but its medium. When the ground stopped connecting people, complexity had to find new vessels, clay tablets instead of spoken roots, granaries instead of seasonal camps, walls instead of the open negotiation of shared space. This translation was not seamless. Things were lost. The fluid gradient-based understanding of the world that a connected landmass encourages the sense that difference increases slowly with distance rather than appearing suddenly at borders gave way to a more categorical understanding. Here and there, inside and outside, ours and theirs, These distinctions, which feel so natural to modern minds raised in a world of nations and boundaries, are in fact relatively recent cognitive habits products of a geographic condition that forced populations into fixed positions and required them to define themselves in opposition to neighbours they could no longer easily merge with or move away from. These borders that we experience as fundamental features of political reality began in a very real sense as coastlines' edges imposed by geology, not by choice, that gradually hardened into the conceptual boundaries we now take for granted. The knowledge that once moved freely across connected ground did not stop existing when the ground fragmented. It changed form. It became local tradition, regional practice, written record, institutional memory. Each of these forms preserves something of the original knowledge, while losing something else, the breadth, the fluidity, the implicit understanding that what you know is part of a larger web of knowing that extends beyond your horizon in every direction. That understanding, once common to any group embedded in a network of movement and contact, became rare. It survives now mainly in the cultures that maintained mobility longest and in the quiet, persistent sense shared across civilizations that otherwise agree on very little, that the world was once more connected than it is, and that something valuable was lost when the connections broke. Civilizations that had never met, building in the same direction. Roughly 5,000 years ago, within a window of time narrow enough to be remarkable, but wide enough to resist simple explanation, complex societies emerged independently in at least 4 regions of the world that had no meaningful contact with one another. In the floodplains of the Tigris and Euphrates, Sumerian city-states organized labor, codified law, and developed a writing system built on wedge-shaped impressions in wet clay. Along the Nile, a unified Egyptian state constructed monumental architecture, oriented to celestial alignments with a precision that still impresses engineers. In the Indus Valley, the cities of Harappa and Mohenjo-Daro achieved a degree of urban planning standardized brick dimensions, sophisticated drainage systems, consistent street grids that would not be matched in Europe for millennia. And along the Yellow River, early Chinese societies were developing bronze metallurgy, ancestor veneration practices, and administrative systems that would eventually produce one of the longest continuous political traditions on the planet. These 4 civilizations did not learn from one another. The distances between them, the deserts and mountain ranges and seas that separated them, the absence of any evidence of sustained early contact all confirm that each arose from local conditions responding to local pressures. And yet the structural parallels between them are striking enough that they have generated debate for over a century. Each developed agriculture independently converging on the same basic strategy of selecting and cultivating cereal grains, wheat and barley, in the West. Rice and millet in the East, despite working with entirely different plant species and entirely different climates. Each developed irrigation systems to manage water in landscapes where rainfall alone was insufficient. Each produced social hierarchies in which a small elite controlled surplus resources, while a larger population provided labour. Each developed symbolic systems for recording information, though the specific symbols and media differed dramatically. Each oriented significant structures to astronomical events, solstices, equinoxes, the rising of particular stars, suggesting that celestial observation served not merely practical, but organizational functions, synchronizing collective activity around shared temporal markers. The conventional explanation for these parallels is convergent development. Similar problems produce similar solutions. River valley environments with seasonal flooding create similar agricultural pressures. Surplus grain creates similar social dynamics. The need to coordinate labour across large populations creates similar administrative demands. This framework is robust and well supported. It does not require any exotic mechanism. It requires only that human beings facing analogous environmental constraints respond with analogous strategies, and in most cases that is almost certainly what happened. But the depth of the parallels occasionally extends beyond what environmental analogy alone comfortably explains. The orientation of monumental architecture to astronomical events, for instance, is not a necessary consequence of agricultural surplus. Many complex societies could have organized their ceremonial calendars around purely local markers, river flood cycles, seasonal temperature changes, biological indicators like flowering or migration, without ever developing the precise astronomical observation required to align a stone structure to within fractions of a degree of a solstice sunrise. The fact that multiple independent civilizations invested enormous resources in exactly this kind of precision suggests not just a practical need for calendars, but a shared cognitive orientation toward the sky as an organizing principle, a tendency that may predate the civilizations themselves by thousands or tens of thousands of years. If early human groups across a connected landmass had already developed the habit of synchronizing behavior to stellar and solar cycles, as the evidence from oral traditions and ethnographic parallels suggests, they might have. Then the astronomical precision of later monumental architecture becomes not an independent invention, but an elaboration of something much older carried forward in cultural memory, even after the geographic conditions that originally fostered it had changed beyond recognition. The same logic applies more cautiously to social organization. Hierarchy is often presented as an inevitable consequence of surplus. Once there is more than enough, someone will control the excess. But the specific forms that early hierarchies took share features that surplus alone does not predict. Priestly classes mediating between a community and celestial or natural forces appear in all four of these early civilizations, and in many others besides. The association of political authority with cosmic order. The idea that a ruler's legitimacy derives not from military strength alone, but from alignment with larger patterns of time season and celestial movement recurs with a consistency that environmental determinism struggles to fully explain. It is possible, even likely, that these parallels reflect universal features of human social cognition rather than shared cultural inheritance. Humans everywhere tend to seek legitimacy through association with forces larger than themselves, but it is also worth noting that the specific form this tendency takes, in linking authority to astronomical knowledge and seasonal regulation, is precisely the form that would develop most naturally in cultures with deep traditions of sky-based time-keeping traditions that a connected landmass would have fostered, and that geographic fragmentation would have preserved in localized, increasingly formalized versions. None of this resolves into a clean conclusion. The parallels between early civilizations are real, but their explanation remains genuinely contested, distributed across a spectrum that runs from pure convergence at one end to deep shared inheritance at the other, with most serious scholars occupying positions somewhere in the uncomfortable middle. What can be said with reasonable confidence is that these civilizations did not emerge from nothing. Each was preceded by millennia of cultural development that the archaeological record captures only in fragments, stone tools, fire residues, burial practices, scattered symbolic objects. The visible civilizations are the tips of processes that reach far deeper into time than their monuments suggest, and the deeper those processes reach, the closer they approach a world in which the land was more connected, the sky was more universally shared, and the conditions for cultural transmission across distance were more favorable than anything that has existed since the oceans finished widening into the barriers we know today. The instinct that outlived the land. If the geographic conditions that shaped early human behavior have been gone for thousands of years, why do the behaviors of themselves persist? This is not a rhetorical question. It is an empirical one, and its answer matters for understanding not just the past, but the present. Modern humans live in a world of hard borders, political, linguistic, oceanic, and yet the impulse to cross those borders remains one of the most consistent features of human culture across every era and every region. We build bridges before we build walls. We develop trade routes before we develop tariffs. We learn other languages even when our own suffices for daily survival. We feel with a persistence that rationality alone does not fully explain that the people beyond the horizon are more like us than different from us, and that reaching them is worth the effort and the risk. This impulse is so deeply embedded that we rarely examine it. We treat it as natural as simply what humans do, but every behavior that feels natural was shaped by conditions that once made it advantageous, and the conditions that reward an instinct for connection over long distances are precisely the conditions that a connected landmass provides. Consider how children draw maps before they are taught cartography. They almost invariably draw land as a continuous surface, a single ground extending in all directions, sometimes with water added as a secondary feature, but rarely as a dividing force. They place people, animals, and houses on an unbroken plain. The ocean, when it appears, is typically a border element rather than a central organizing feature. This is not sophisticated geographic knowledge. It is intuition, and it reflects an expectation about how space should behave that formal education must actively override. We teach children that the world is divided into continents separated by oceans. We do not teach them that the world is continuous because they already assume it is. That assumption does not come from experience. Most children have never walked far enough to test it. It comes from somewhere deeper, a cognitive default that treats connectivity as the baseline and fragmentation as the exception requiring explanation. Whether this default is inherited, culturally shaped developmentally, or grounded in some deeper evolutionary tendency is an open question, but its existence is not in doubt. Humans expect this ground to continue. When it does not, they feel the interruption as a problem to be solved rather than a condition to be accepted. This expectation shows up in language with striking consistency. Across unrelated language families, metaphors for understanding, agreement, and cooperation are overwhelmingly spatial and connective. We speak of finding common ground, of bridging differences, of building connections, of reaching across divides. Metaphors for disagreement and conflict, by contrast, invoke separation, being far apart, being on different sides, being divided. These metaphors are so pervasive that they feel transparent, as though they describe relationships directly rather than mapping physical experience onto social abstraction. But that mapping is itself revealing. It indicates that the human brain, when searching for a framework to organize social experience, defaults to spatial models in which proximity equals understanding and distance equals estrangement. A brain shaped entirely by a fragmented world of islands and isolated valleys might just as easily have developed the opposite default, treating separation as normal and connection as exceptional. The fact that it did not suggests that the formative conditions, the conditions under which these cognitive defaults were established, favoured a world in which connection was the ordinary state of affairs and distance was measured in effort rather than impossibility. Modern technology viewed through this lens becomes less a story of innovation and more a story of restoration. Roads reconnect what rivers and mountains divided. Ships reconnect what oceans separated. Telecommunications reconnect what distance attenuated. The internet, in its most fundamental function, recreates at electronic speed the condition that a connected landmass once provided. At walking pace, the ability to transmit knowledge across vast distances without requiring the physical movement of the person who carries it. We celebrate these technologies as achievements, and they are. But the desire that drives them is not new. It is ancient, shaped under conditions that no longer exist geographically, but that persist cognitively, embedded in expectations about how the world should work and how people should relate to one another across space. Every time a new communication technology is developed, it is adopted with a speed and enthusiasm that suggests it is filling a need that predates the technology itself by orders of magnitude, not creating a new behaviour, but satisfying an old one that geography had temporarily frustrated. Even the emotional register of modern life carries traces of this older orientation. Loneliness, the specific pain of feeling disconnected from others, is not merely a social inconvenience. It is increasingly recognized by medical research as a physiological stressor, comparable in its health effects to smoking or chronic sleep deprivation. The human body responds to social isolation as though it were a survival threat, because for most of human evolutionary history it was. Isolation on a connected landmass did not mean solitude by choice. It meant separation from the network that provided safety knowledge and reproductive opportunity. The body learned to treat disconnection as danger, and it has not unlearned that lesson despite millennia of living in a world where isolation is common and often voluntary. We carry in our nervous systems an alarm, calibrated to conditions that a connected landscape imposed, an alarm that still sounds faintly, but persistently, every time the distance between ourselves and others feels wider than the ground beneath us was once designed to allow. This ground remembers what we forgot. Somewhere in the middle of the Atlantic Ocean, roughly equidistant between the bulge of West Africa and the coast of Brazil, a ridge of volcanic rock rises from the seafloor like a scar that never quite healed. The mid-Atlantic ridge is not a ruin. It is an active boundary, a place where the Earth's crust is still pulling apart at a rate of approximately 2.5 centimeters per year, roughly the speed at which a human fingernail grows. That measurement sounds trivial until you multiply it by time. 2.5 centimeters per year, becomes 25 kilometers per million years, becomes thousands of kilometers across the span, since Pangea's interior first began to stretch and thin. The Atlantic Ocean, which feels so permanent and so vast when viewed from a modern coastline, is in geological terms a recent and still deadening crack. It is not a fixed feature of the planet. It is an ongoing event, a separation still in progress recorded in the symmetrical magnetic striping of the ocean floor, where new crust forms, cools, and is pushed outward in both directions like a slow conveyor belt carrying the continents incrementally further from each other with every passing year. The ground beneath the sea remembers exactly when and where the splitting began. It has been keeping records far longer than any civilization in a language written in mineral alignment and thermal gradients, rather than symbols on clay. This is not a poetic conceit, it is measurable, testable, and confirmed by decades of oceanographic research. The Earth maintains its own archive, and that archive is more complete and more honest than any human record has ever been. It does not editorialize, it does not compress time into narrative, it simply preserves the sequence of events in the order they occurred layer by layer, stripe by stripe, with a fidelity that human memory, even at its most disciplined, cannot approach. When geologists read the ocean floor, they are reading a document that began composing itself over 170 million years ago and has not stopped since. Every centimetre of new crust is a new entry. Every magnetic reversal is a timestamp. The story it tells is one of slow, patient, irreversible separation. A world that was once whole becoming incrementally, and without drama, a world of parts. What is striking about this process is not its violence, but its quietness. Continental drift does not announce itself to the creatures living on the surface, or no generation of humans has ever felt the Atlantic widen. No community has ever woken to find that the coastline moved overnight. The change is real, but imperceptible at the scale of a human life, which means that every generation experiences the world as stable, even though no generation inhabits quite the same world as the one before. This mismatch between perception and reality is itself a kind of inheritance. We are adapted to trust the ground. We build on it, plant in it, anchor our identities to it, and assume that it will remain where it is. That trust was shaped under conditions where the ground for all practical purposes within a human lifespan did remain where it was. The trust is not wrong. It is simply incomplete. The ground is stable on the timescale that matters to a single life. It is restless on the timescale that matters to a species. Pangea will reassemble, not in its original form, not with the same configuration of plates, and not for hundreds of millions of years. But the tectonic cycle that built it, the slow convergence of land masses driven by mantle convection, has not stopped operating. Geologists have proposed several models for the next supercontinent, with names like Pangea Ultima and Amasia projected to form roughly 200 to 300 million years from now. The continents are still moving. Africa is pressing northward into Europe, closing the Mediterranean at a pace that will, given sufficient time, eliminate it entirely. Australia is drifting towards Southeast Asia. The Pacific Ocean is slowly narrowing. These movements are too slow to affect any human plan or any human civilization, but they are a reminder that the current arrangement of the world is not its final state. Separation is a phase. It has happened before, it is happening now. And it will eventually reverse, as it always has, in the deep rhythm of a planet that cycles between unity and fragmentation, the way a living system cycles between breathing in and breathing out. This perspective does not diminish the human story, it contextualizes it. Humanity arose during a particular phase of that cycle, a phase of fragmentation of widening oceans and hardening borders of isolation that forced creativity and settlement that demanded new forms of memory. Everything we recognize as civilization, agriculture, writing, architecture, law, nation-states, digital networks emerged under those specific conditions as responses to the constraints that a fragmenting planet imposed. Had the timing been different, had the continents been closer, had the land bridges lasted longer, the responses would have been different too. Not necessarily better or worse, but shaped by a different set of pressures, producing a different set of solutions, leaving a different kind of record. Or perhaps no record at all if the solutions favoured movement over settlement and memory over monuments. We cannot know what was lost when the paths flooded. We cannot recover the knowledge that travelled on feet across ground that is now ocean floor. We cannot reconstruct the oral traditions that frayed when contact between distant groups was severed by rising water. What we can do is notice the patterns we observe in myth, in language, in the distribution of cultural practices, in the deep cognitive defaults that shape how humans relate to space and to one another are consistent with a long period of connectivity that preceded the fragmentation we now take for granted. That consistency does not constitute proof. It constitutes an invitation to hold the question gently, to resist the premature comfort of certainty in either the direction, and to remain attentive to the possibility that the world beneath our feet has not yet finished telling us everything it knows. The ground is patient. It has been keeping its records for far longer than we have been asking our questions. And the distance between what it remembers and what we have so far understood is still, after all this time, quietly and immeasurably vast. In 1912, a meteorologist placed two fossil impressions side by side and noticed that the leaves matched. The fern had been dead for 250 million years, yet its shape pressed into stone on opposite sides of an ocean that had not existed when the plant was alive, still fit together, like a page torn slowly down the middle. We began this evening with those two pieces of rock held in careful hands, asking a quiet question about what else might once have been whole. We have travelled a long way since then through interior deserts that baked under skies no human eye ever saw, through transitional zones where flexibility mattered more than strength, through land bridges that rose and sank with the breathing of ice ages, through fire carried in green leaves and knowledge carried in voices that left no residue harder than air. And now, from this distance, those two fossil impressions look different than they did at the start. Not larger, not more certain, but somehow deeper, as though the silence between them contains more than it did before we began listening. We have not answered the question this evening posed. That was never the intention, and it would not have been honest to pretend otherwise. The gap between Pangea and humanity is too vast for any single thread of evidence to bridge. The patterns we traced in myth, in toolmaking, in the architecture of flood narratives, and the distribution of stellar stories, in the strange structural echoes between civilizations that never exchanged a single word. These patterns are real, but their meaning remains genuinely uncertain. They may reflect deep inheritance carried across connected ground and preserved in cultural memory long after the ground itself fragmented. They may reflect nothing more than the predictable output of a single species solving similar problems with similar brains under similar skies. Both explanations are credible, neither is complete. And the space between them is not a failure of knowledge. It is simply where we are standing at the edge of what can be demonstrated, looking out across what can only be wondered about, aware that the distance between the two is not empty, but filled with a kind of silence that deserves patience, rather than premature conclusions. History does not arrive to us clear. It arrives in layers of sediment, compressed and partial bias toward whatever happened to be made of stone or fired clay or metal, the materials that outlast the centuries, while everything softer dissolves back into the soil. What was spoken is gone. What was walked is gone. What was known through practice and transmitted through demonstration and carried in the rhythms of seasonal movement across landscapes that no longer exist in their former shape. All of that returns to silence, not because it was insignificant, but because significance and durability are not the same thing. We read what survived. We wonder about what didn't. And the wondering is not weakness. It is the honest response to a record that we know with certainty is incomplete. Perhaps the ground beneath you right now was once pressed against ground on the other side of the world. Perhaps the stone under your city, your street, your bed carries in its mineral composition a memory of a different arrangement, a time when distance meant something else, when the horizon always led to more land, when the idea of an edge had not yet entered the vocabulary of the earth. You will not feel it. The drift is slower than stillness, but it continues tonight as it has for hundreds of millions of years, carrying everything on its surface, including you, toward a configuration that no one alive will ever see. Let that be enough for now. Not a conclusion, not a revelation, just the quiet awareness that the planet has been rearranging itself for far longer than anyone has been asking why, and that the questions we bring to it about connection, about loss, about what might have existed before the record begins, are themselves a kind of continuation. A species wondering about its own past is a species still in conversation with the ground it stands on. That conversation does not need to end tonight. It does not need to reach a resolution. It only needs to rest the way a path rests under snow, still there, still shaped by the feet that made it, waiting for no one in particular, patient beyond any human measure of patience. Sleep well, traveller. The ground beneath you is older than memory, and it is not finished moving, but tonight it holds still enough.